So today we're going to talk a little bit about graphing with asymptotes, but we're not going to do graphing in your homework until Monday. All right? So there's some things that you got to be able to find. You got to be able to find your x-intercept. How do you find your x-intercept in an equation? Yeah.
It's your zeros.
That's your zeros, isn't it? What makes your equation go to 0? So when y is 0, those are your x-intercepts. So what you're going to do here, you're going to have fractions that you're dealing with. So set your numerator equal to 0 and solve it. How do you find your y-intercept?
Denominator equals 0.
Let x equal 0 and then solve. So you plug 0 in for all of your x's and solve it. Okay? Then you're going to need to find your vertical asymptotes. So what we're dealing with today, it's all about the denominators and numerators. So here we're going to set your denominator equal to 0 and find the 0 of your denominator. You can say that. Find the 0 of your denominator. Okay. So we're wanting zeros of your denominator. Yeah.
Is this where, like, you got 2 lines and they don't like
Let's go. Yeah, at least. Okay. All right. So that's that. Then we have the horizontal asymptote. Okay. If the denominator is greater than the numerator, and we're talking about degrees, the bottom degree is greater than the top degree, then your horizontal asymptote is y equals 0. If the denominator is equal to the numerator, if they're the same, okay, then it's the leading coefficient. The top leading coefficient over the bottom leading coefficient. We're going to do an example that shows all this. And then if your numerator is greater than your denominator degree, okay, then you have to do long division. And we call this a slant asymptote. It's no longer horizontal. We'll do an example of each of these, okay? What? You gotta memorize this. Because you're not gonna get this, have this for your quiz or your test. Alright, let's do some examples. This is number 22. Y equals, R of x equals 2x minus 3 over x squared minus 1.
Yes.
What?
Can't see it.
Okay.
Oh.
What do you mean you can't see that?
That's because that thing.
Oh, it's in the glare of the
Yeah.
bulb? Oh, that's too bad for you. It's 2x minus 3 at the top, x squared minus 1. Okay? Does it help if I pull the screen down?
No.
Okay. X-intercept. What do we gotta do? Set the numerator equal to 0. So here's what you're going to do in your papers. X-intercept. 2x minus 3 equals 0. What do you get when you solve that? Set the numerator equal to 0 and solve.
3 halves.
3 over 2. That is your x-intercept. Y-intercept. What do we do?
What x equals 0?
All the x is equal to 0. So 2 times 0 minus 3 and 0 squared minus 1. What do you get? Work it out. Negative 3 over negative 1, which is positive 3. That's your y-intercept. Alright, and then you're going to say vertical asymptote. How do we find the vertical asymptote? The zeros of your denominator. So x squared minus 1 equal to 0, and solve it. Everybody solve it. What do you get? Add 1 to x squared. The square root of 1 is plus or minus 1. Okay. So you have two vertical asymptotes, one positive 1, one negative 1. Anybody lost? Nothing new. Alright, horizontal asymptote. Look at the degrees. What do you notice about the degrees? The exponents. What's the highest exponent? Number 1? Or in the numerator?
1,
1. What's the highest exponent in the denominator?
2.
2. So which one's bigger? Denominator's bigger? Y equals 0 is your horizontal asymptote. Great, let's graph it. Now you've all been taught that you cannot cross your asymptotes, right? The lines will never touch the asymptotes. That's not true. Asymptotes are just lines that don't even exist, and what we use them for is the end behavior of your curves. As the line curves, it's approaching some line that's not there. Now, it can still cross that line somewhere in the middle, somewhere, but then eventually the end behavior of your curve approaches that line. So what you've been taught is true except for somewhere in that line that doesn't exist, it's okay to cross it. It's just the end behaviors of your lines, either the vertical or the horizontal asymptotes. The end behavior of your lines, they're approaching those things. So no longer think that you can't cross an asymptote. That's not true at all, which you'll see. Let's all graph all this. X-intercept's at 3 halves. It's 1.5. Y-intercept is at 3. Vertical asymptote is plus or minus 1. Listen. And the horizontal asymptote is at y equals 0. And if you notice, one of your zeros is right on the asymptote. So in this example, we are going to show that it does cross the asymptote. But the end behavior is what you want to look at. Okay? Alright, now, we got a lot of asymptotes here. Notice there are no zeros on the left. That means we're not crossing the x-axis. Which means either the line looks like this, you don't have to draw it, or it looks like this. It's one of the two. All I need to know is what the value of the polynomial is at any of these points left of x equals negative 1. So if I plug in negative 2, I just need to know if it's positive or negative. And that will let me know which one of these it is. So, negative 2. 2 times negative 2 is?
Negative 4.
Negative 4 minus 3 is? Negative? Negative 2 squared? Minus 1, which is positive. What's a negative over positive? Negative. So it's the bottom one. approach that. Now, there's nothing, I don't know exactly what this looks like. It could go like this, all the way over to the corner and then down. If you want to get more accurate, then you can plot more points. Okay? That's the first part. Now we need to know what happens here. Now, you're going to have to use your logic here. Are there any zeros? No. Okay? That means we're not crossing the x-axis. So, it's going to approach from the left, hit here, and then go up. I don't know if that is a vertex. That's why I drew it like that. It looks like it is, but we don't know that for sure. Okay? Now, if this point wasn't here, we'd have to do the same thing here that we did over here, but we do have a point. So we're crossing this asymptote somehow. Either we're going to cross it like this and come back to there, or we're going to cross it this way and come back. The only way to tell that is to plug in a point and see what we get. So let's plug in the value of 2. 2 times 2 is? Minus 3. Positive. 2 squared. Minus 3. Positive. So at 2, we're up here. It's actually 1/3. Alright. So as soon as, or once we get past the 0, we're right here. So we know it's going to come from the bottom, and then it's going to come back down and get closer with the end behavior there. Now everybody get your graphing calculators out. And put this in your graphing calculator. That's what it should look like. 2x minus 3. Make sure you use parentheses because your fraction is a grouping symbol. Make it a little darker. That's a little better. Okay, then when we graph it, that's what it looks like. So we need to change the window setting a little bit. It looks, well, this part we got right. It's coming down through this point here somehow, and we can't tell what's going on, but then it goes down here and up. So we need to actually zoom in to see a little better picture, because it doesn't look like we drew it right, but we need to make sure. So hit zoom, hit the number 2 for zoom in. And then arrow up just a little bit and over, about right there. Now we can see kind of both the right side and the middle, and hit enter. Okay. So these 2 lines are your asymptotes. The graph goes up just like what we had it. Notice that that point was not a vertex. And then this one comes up, and then it'll start to come back down towards the other asymptote. Okay? So you will have your graphing calculators to look at, but on the quiz you will not. On the test I'm still trying to decide to let you use it. So you're going to have to be able to do what we just did. Alright? Now you're not graphing on tonight's homework. We're going to do that, save that for Monday. But I want you to see what it looks like. Alright, let's do another one. Okay? Next example. All right, let's do. I'll put it over here so Vito can see. Let's do example 32. X cubed plus 3x squared all over x squared minus 4. Start and find the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote, and I'll help you with that. How do we find the x-intercept?
Numerator equals
Numerator equals 0. So we want to factor out an x squared. So x equals 0 or negative 3. Did you all get that? Alright, you're all such wonderful students. That was easy, right? You're just finding zeros, just like what we've been doing the last 2 chapters. And since 93. Y-intercept. How do you find the y-intercept?
X equals 0.
Let x equals 0, so 0 cubed plus 3 times 0. Stop right there. What's the numerator? 0, so
Who said that?
0 plus 0 is 0. If you have 0 in your numerator, the answer is 0. Alright, vertical asymptote, how do we find it?
Denominator equals
Yeah,
0.
the zeros of your denominator, so everybody said the denominator equals 0. Solve it, please. Good. Now, horizontal asymptote. What do you notice about the degrees?
degrees on in the numerator are greater than.
And what does it tell you to do? Long division. X cubed plus 3x squared plus 0x plus 0 divided by x squared minus 4. Do not forget your placeholders. Everybody do long division. Tell me what you get. Long division, man. Come on, you need more paper than that to do long division. Oh my goodness. Maybe we should have more quizzes. What times x squared gives me x cubed? X, 1. X times x squared is x cubed. X times minus 4 is minus 4x. Keep them in the right columns. Subtraction changes the signs. 3x squared plus 4x plus 0. What times x squared gives me 3x squared? 3. 3x squared, and then we have a minus 12. Again, put them in the right columns. Subtraction changes the signs. 4x plus 12. That's your remainder. This is the slant equation of a straight line. That is your slanted asymptote. So there's no horizontal asymptote. If the degree in the numerator is bigger than the denominator, then you have to do long division to find this. Right. Having said that, it goes through 3, has a slope of 1 over 1. So there's this line, this invisible line. Our x-intercept's at 0 and negative 3. Oops. Notice that your 0 is on the asymptote. And the y-intercept is at 0. Obviously, if the x-intercept is 0, the y-intercept is 0. vertical asymptotes are at plus or minus 2. So you're gonna have to do this on your quiz. So I'm gonna give you a problem like this, and this is exactly like what the quiz is gonna be like. X-intercept, Y-intercept, vertical asymptote, horizontal asymptote, graph, 5 points. So on Tuesday, at your quiz, not Monday, I'm gonna give you a problem, and then you have to tell me all those things. Alright? Without a graphing calculator. Alright, so we know it crosses this. The question is, what does it look like? Well, let's plug in some values. If I plug in -4, what do we get? And let's actually figure out what it is. -4 cubed is? Don't hurt yourself. Okay? -4 squared
60.
times 3. I didn't know pre-algebra students were so smart. -4 squared
60.
minus 4. -64 plus 48.
Yeah, got it.
-16 over 12, which is? Alright. So, at -4/3. So we're about right here. Okay, smarties, since you're all so smart. -100. Positive and negative is what I want here. Look at your leading degrees. Is the numerator going to be positive or negative?
Positive.
The negative to the third power is negative. What about the denominator? Positive. So, is the whole value positive or negative? It will be negative. Now, if the top number is infinitely larger than the bottom number, do we have a big number?
Yeah.
Well, let me ask you. 1 over 1, oops, 2 over 1, 5 over 1, 100 over 1. If the top is getting infinitely larger than the bottom, isn't your value very large?
Yes.
Hello?
Yes.
Yes. But this is negative, so the top is negative, bottom is positive. So these are negative. So this is getting, as we go out here, it's getting very, very large in the negative on the y-axis. Okay? What about what happens right here? We're going to talk about that. We'll put it in the graphic calculator to save time. We're running out of time. Right here, there's nothing saying that it's crossing this. So again, we're going to assume it does this. We don't know if that's the vertex or not. And then we have this over here. There is no 0 over here, is there? So it better not be. I mean, if I'm over here at all, it's going to cross that x-axis. But there is no 0, so it must be up there. Alright, so now I want you to use your graphing calculator, plug that in, and see if we can get the right window to look at. What is that, x cubed? Plus 3x squared. X squared minus 4. That's how you should put it in your calculator. Who's got the calculator? Raise your hand. Okay, how to give the rest of you zeros. Bring your calculators to class. Graph it. Oops. Oh, we got that part right. You can't see the rest, so let me zoom out. You can at least see that middle part.
Sweet calculator.
Zoom 6. Notice it's just, and then at the very top there, you can see what we had was correct. But this is following this asymptote this way, right along with it, and then it crosses the asymptote and goes up that line that we had. Like that. that's what it looked like. So, as you can see, that's what that is. Okay? So use your graphic calculators to help you. Make sure you can do these 4 steps, and that you understand the horizontal asymptote and the slanted asymptote. If, everybody look up here, if, let's just do this real quick. Let's say I had 8x cubed and 4x cubed here. What are you supposed to do when the degrees are the same? Read, participate. The leading coefficients, what are the leading coefficients? 8 and 4, what's 8 over 4?
2.
Y equals 2 would then be your horizontal asymptote. That's how you do this. Alright, so you're not graphing today. You're going to start off by plugging in values for x and getting a value for y. And then you're going to identify what your x and y intercepts are in the next set. And then the next set after that, they're going to ask you for the vertical and horizontal asymptotes. And then on Monday, we'll work on the graphing. Your assignment is page 289, 7 to 31 odds.